Okay, so we're going to continue with a demonstration of our implementation of PSL, and we're going to start by installing that implementation, and then we'll run a basic example program and sort of go through how to implement in code some of the ideas we've talked about and how to then apply the software to your own problems. So the first thing to install PSL and PSL example programs is to make sure that you have the necessary prerequisites. And the first is Java 6. I'm also told that it generally works on Java 7, but we haven't tested that as much. So it's all written in Java, and you'll need that. And the other one, the other thing you need to install is Maven 3, and be sure that it's version 3. I know that Maven 2 will not work. So Maven 3 is kind of a combination of a dependency manager and a build manager, and so that'll take care of installing all the other prerequisites and setting up the code. So once you have those installed, the next thing you want to do is go to the PSL website, and the URL is here. It's psl.cs.umd.edu, and you'll see three main areas. And so the first is the source code, which we'll come back to. You can also find a list of PSL-related publications, not an exhaustive list, but many of the core publications and applications of PSL. And finally, a user group that's on Google right now, and so if you have any questions about using PSL, using either the software or questions about the formalism, that's a great way to get help. But we're going to focus on the source code over here, and we're going to go to that, which will take you to our GitHub repository, and that's this. And so on this GitHub repository, we have a stable branch that, or a master branch that always points to the latest stable version, as well as development branches. But we're going to go over to the wiki right now. And that'll give us some of the necessary commands to install PSL. So we're going to go to the wiki. And once you're on the wiki, you can go down to the table of contents and find the installing examples page. And that'll look something like this. And then, of course, the URL is also at the top right here. And once you are there, you should have something that looks like this. Okay. And so what this page gives us is the Maven command we need to install an example program for PSL, which will set up everything we need, also all the dependencies and the PSL libraries itself. So from the command line, you're just going to copy and paste this command. And that will install the example program. And if this is your first time running this command or using Maven at all, this will probably take a lot longer on your machine because it will have to download a lot of different things. And then you'll get to this prompt at the end where it asks you to set some values for the project you're creating. And all the default values are already filled in. You just want to hit Y for yes and hit enter. And you should get build success. Okay, and that means we've installed the PSL example programs. So let's go into that directory. I'm just going to change into PSL-example. And you'll see source files, the POM file, which is what Maven uses to store metadata about the project, and data for the experiments you can run in the example. So from here, I'm going to switch over to Eclipse, and opening up these things in Eclipse is easy. There's some more details on the wiki, or you can find them on various places on the web, but basically the command is maven mvn eclipse : eclipse. I'm going to run that to set up an Eclipse project, and again, this will probably take a little bit longer to run it on your machine if you've never run this before. And once again, we get build success. There's some warnings about missing Java docs and source archives. Not all of those are available. You can also run them with additional parameters if you want to Maven to search for those. But this is fine for now, so we'll go with build success. And then we can jump over to Eclipse and go to File, Import, and existing projects into Workspace. And we will browse over to our directory that we created, PSL example, open, and hit finish. Okay. And so now we see that over here, we see that same directory that we created, PSL example. And within the source directory, you've got main Java, where the actual files are stored, as well as source main resources, where properties files are stored, and we'll talk about those in a little bit. So let's go to basic example.groovy. Okay? And the first thing to notice is that PSL has what's called a Groovy user interface. And Groovy is a Java-based scripting language that acts as a superset of the Java language and gives us some additional syntactic sugar, which we'll see makes writing PSL rules a little bit easier. And so the way it's all set up is Maven will install the necessary libraries to run Groovy. If you don't have Groovy support in your Eclipse installation, you might have to install that as an add-on. Otherwise, you can use some other editor. But Groovy will then get compiled into Java bytecode and run like regular Java class files. Okay, so you'll notice that a lot of this looks like Java. You've got your package declaration, your import declarations, and then we get to actually setting up an actual PSL program. And the first thing to notice is that we load in some configuration files to start. We grab the config manager singleton, and we grab the config bundle. And the config bundle is tied to this PSL properties file over here. So it looks for the one in source main resources, and this lets us specify what are called bundles and configuration keys and then configuration values. So a bundle lets you specify a set of options, and then specific classes in the PSL library give you lots of keys to override default values for. But that's where that is. So if you know that you're looking for a particular option, that's where you can find it. And so we get the bundle that is called basic example. Now you'll note here that right now there are no options for that bundle, and so it's loaded as an empty bundle. Okay? And the next thing that happens is we set up the RDBMS backend for PSL. So because we're going to be working with a lot of data, we're going to be working with relational data, we use a storage backend to help with all of the data management that has to get done. And so what we do is we set up a database path that will by default go to a temp directory, or you can override this with by specifying basic example.db path in your config bundle. So that would be a valid configuration option. And I got that bundle and key name from this bundle here and this key name here. Okay, once we have that path, we set up an H2 database backend. And we specify that it's going to run on disk as opposed to memory, and it's going to be at this path. And we're going to put a true here, which just means whether or not the database should be reinitialized if it already exists. So this means erase it if it already exists, and then start over. And then most constructors in PSL will take this config bundle. Okay, so now we've set up that stuff and gotten that out of the way, and we get to the core object that we're going to be working with, which is a PSL model. And the PSL model is just the set of rules and constraints that we're going to use to define a model, or excuse me, define a ground model when we apply it to data. So it takes two arguments, this, which is just the instance that this Groovy file creates when it's run, and so that's going to let us do some syntactic sugar to help us run this. And then the second thing we pass in is this data store. And now we get to defining the actual components of our PSL model. So remember earlier we were talking about the things that make up a PSL program, and they're things like predicates. Well, the first thing we define are these predicates. But before doing that, we have to decide what it is we want to model. What predicates are we going to be interested in modeling? And so in this example, we have a data set with two social networks where people, and we want to figure out whether two people in the same network are, excuse me, two people in two different networks are actually the same person. So maybe somebody signed up for two different social networks, but maybe they use slightly different names. And so we want to see if they are, in fact, the same person. But of course, this is statistical relational learning, and so we're not going to make these pairwise judgments in isolation. We're actually going to do them all jointly. And there, the social structure, the structure of the two social networks is going to help us. And we'll get more into that when we talk about rules. But so predicates capture the basic data that we're going to be working with. And so we have three predicates in this example. The first one we have is name, and so entities in, or excuse me, references in our two social networks are going to have names. And so what we do is we say to this model we want to add a predicate name, and then we have to specify argument types. And the first argument type is a unique ID, and the second argument type is a string. And so how do we pick these argument types? Well, unique IDs are things that are like primary keys or foreign keys for atoms, and so, excuse me, for entities in your relational data. And so if you expect it to be a unique identifier, it's good to specify that in the argument type in PSL. This will also mean, in the current implementation, the underlying data store will create indices on argument types that are unique IDs, so that'll probably give you a performance boost. But if you have strings like people's names in these social networks, then obviously that's a string, and then other types are integer and double. And then we have the social relationships in these two social networks. Our second predicate is nodes, and so this takes two unique IDs because we have relationships among the references in our social networks. And finally, we have the same person relationship, same person predicate. And this is the one we're actually going to try to predict. And again, the argument types are two unique IDs because we're going to say that two references, one in each of the two social networks, actually refers to the same underlying entity. And so that's why we pick these argument types. And the next thing that we can do with PSL is we can define custom functions to use in our model. And so this is one of the strengths of the PSL implementation, that it's very easy to define custom functions for to use as features. And so a very common thing to do in entity resolution is look at the string similarity of names in your data, right? And so we have this same name function that we're going to be using, and that's going to measure how similar two names are, two strings are. So it'll be closer to 1.0 if the names are similar, and closer to 0 if they're not at all similar. And so PSL provides some implementations of different string similarity measures that you can use. And so this one will use a common one called the Levenstein similarity, but it's also very easy to define your own. And so I'm going to jump to the end of the file for a second and give an example it's very easy to define your own implementation. All you have to do is implement this external function interface. All you have to do is specify the arity, the number of arguments that it takes, an array of argument types. So here we see that we want this string similarity function to operate on 2 strings naturally. And then we define a get value function where the value is actually computed for particular arguments. And in addition to getting an array of ground terms, which the system will ensure is the right number and type as you specified up here, you also get what's called a read-only database. And that's going to let you access some of the read-only data that you've specified. We'll get to how to do that a little bit later. But any closed predicate, any predicate that you say, I have observed all the atoms of this predicate, will also be accessible. And this will let you come up with more complicated network-based functions and more rich database functions based on the data in your data set for computing these features. So that's how you define your own external functions, your own feature functions. Now I'm going to jump back up to where we define that in the model, and that's back up here. Okay, so now we've defined all of these primitives that we want to use. We've defined predicates and feature functions, and now we're going to put them together into rules. Because remember, in PSL, rules are the one of the basic templates that we use to define relational dependencies, things that we expect to hold in our data, or things that we want to learn parameters for to see if they hold in our data. And we get to our first rule here. I'm going to make this a little bigger. So before diving into the syntax, let's just talk about the intuition. What we want our rule to do is say that if 2 people have similar names, then it's likely, it's probable that they're the same person. So that's the intuition we have in our head. That's the relational dependency that we want to include in our model. And this line of code actually implements it. And so the first thing we do is we say if there are 2 people, A and B, with names X and Y. And then we say, we include a little syntactical shorthand for saying only ground out one of the 2 symmetric cases. So of course there's 2 possible substitutions for A and B, and then there's a symmetric substitution where you just substitute B for A and A for B. And so what this does is say just include one of them. Okay? So what we've said is up to this point is just give me 2 people for every 2 people with 2 names. That's what these 3 literals do. And then we say, and they have a similar name. Okay? So if 2 people, A and B, have similar names X and Y, then these 2 arrows mean implication, then they're the same person. Okay? And that's what this rule says. And finally, we specify a weight. And for now, we're just going to hard code this weight, but later we'll talk about how to learn those weights. We'll just say that this has a weight of 5. Okay? And that's our first rule. And the next thing we do is we say, we define an aggregate over the set of friends that people have in these 2 social networks. And so this uses some built-in PSL functionality to define a set comparison operator called same friends and measures whether or not the friends are similar. And the people, to determine whether or not the 2 sets are the same, we're going to use this same person predicate that we're trying to infer. Okay. And that brings us to our second rule. If 2 people are the same, then they should have the same friends. That's what this second rule says. And it's defined over the set of people that A knows and knows A. So we have sort of an object-oriented syntax here. We have A.knows union with all the people that know A, and then same with B here. So if 2 people, A and B, are the same, then the sets A.knows union A.knows inverse, and the other set B.knows union B.knows inverse should also be similar. We'll give this a weight of 3.2. And finally, we'll add some predicate constraints. Well, we know something about this same person predicate that we're trying to predict, and so we'll put some constraints on the model so that the predictions we make obey these properties. And the first is that we expect it to be partial functional and partial inverse functional. And what this means is that someone in the first social network can align with at most one other person in the second social network, and then the partial inverse functional is the other way, that each person in the second network can align with at most one person in the first network. And finally, we say that it's symmetric, that if A is the same person as B, then B is the same person as A to the same degree. And finally, we'll add one little rule here that just says that with a little bit of weight, people tend not to be the same person. And so what this will do is it will mean that we don't infer that people are the same unless we have some evidence to actually do so. And now we're ready to run this model, and we'll get to this point and it'll print it out. And then in the interest of time, we won't be able to talk much about what the rest of this program does. We'll do that in the next class. Okay, but we're at the point, I'll just run this very quickly and then pick up next time. And so the simplest way to run this is to do it from Eclipse. You just go to Run As and Java application. So in this version of Eclipse and this setup, it's very important to make sure you run it as a Java application, not a Groovy console or a Groovy script. Just save those changes. The first thing it does is print out the model. It runs inference, and it's going to learn the model again, get some new weights, and run inference again on a new data set. And so what you can see, if I scroll up here to the inference results with hand-defined weights, what you should keep in mind is the way the data is set up is that 11 should align with 1, 12 should align with 2, 13 should align with 3, and so on. And so these continuous truth values are the most probable settings, the most probable assignments to the unknown atoms. And what you see is that these hand-defined weights are pretty good for this simple toy problem. So 11 and 1 aligns degree 0.6, and everything else is very small. 4 and 14 again align to degree 0.6, and everything else is very small, and so on. And then also, very quickly, I'll show you how to run this from the command line. And the simplest way to do this is to go back to the wiki and go to the page on running a program. Okay? And these are the 3 commands that you run to compile and then execute a PSL program. So the first thing you do is use Maven to compile it. Build success, everything's up to date because Eclipse also compiled it for us. And then what we do is we prepare our class path. And so one of the things that Maven's going to do for us is going to manage all the jars that hold all the dependencies for this PSL program to run. And there's a substantial number of them. Okay? And that's just going to print out the file, or it's going to write out the class path file. And you can see that it's pretty long. These are all the jar files that our program depends on. Okay? And finally, this third command actually runs it. Okay, and so it includes the local class files as dependencies and also all the jars on the class path file. And all you have to do is provide the fully qualified class name. And so that's edu.umd.cs.example.basic.example. And if you hit enter, this should also run from the command line. Oops. You see we get the same results. So we'll stop for now, and we'll pick up next time with talking about how to set up data sets in PSL and then go through this example in some more depth. Okay, thanks a lot.